Okay, so what I'm doing is the second problem in the empirical formula for those of you who are struggling. We did kind of did the first one in class, we'll do the second one. And so I just copied the formula used before. Now, as I said before, there are 4 steps, which I'll try to do in a different color. The first one is called the mass step. You know we have a magnesium and phosphorus compound. We have to figure out the mass of both parts. So it tells us right here. It's 3.19 grams of magnesium. That's where we start. Just like you start with tin in your lab, you start with magnesium here. Now the compound that weighs more because you've added phosphorus to it. But this 59 is magnesium and phosphorus. So you got to subtract the two. I guess I'll be right here. I take 59 grams and subtract the 31.9 grams, and you'll get, you beat the calculator. When we subtract those two, we'll get an answer in just a second. Okay, so now we'll have our grams of phosphorus. Okay, 27.1 grams of phosphorus. Okay, so we start with the mass, because we can mass things in the lab. And now again, the goal, let's go down here to the goal. What are we looking for? We're looking for the formula, the X and the Y, the subscripts on this formula. And as we learned from water, mass does not tell us formula. Because these subscripts are not in the mass ratio, they're in a mole ratio. So the second step, I'll use blue for, is called the mole step. And in the mole, we set up a ratio or a conversion factor. We know that 1 mole of any substance, Mr. Mole told us this, we have the gram equivalent of the AMU, which to the hundredths place for magnesium is 24.31 grams. These two are equal. 1 mole of magnesium is 24.31 grams, so just do the conversion. Same with phosphorus. I'll need the phosphorus AMU daily. 1 mole of phosphorus is 30 something. You can use my big graph table if ever need to.
Yes.
Thank you. 30.97 grams. Again, these are AMUs right off the periodic table. You don't have to memorize those, you can use the periodic table. So mathematically, what we're going to do is take 31.9 times 1, which of course that's nothing, but then divide by 24.31, which is the AMU. And when we do that, we get it's not going to be 0, it's going to be 1 plus
1.3122.
So the 3 significant digits, 3.12 moles of magnesium. Doing the same thing down here. 1 mole phosphorus, or 27.1 times 1, which of course is 27.1, divided by 30.9, we get
0.875.
moles of phosphorus. All right, so again, we call that's the mole step. Now the next step is, because in this formula, it's a mole ratio, but it also has to be an atom ratio. So we can't have decimals for atoms. You can't have a partial atom. So we're going to convert these to whole numbers, which I'll use red for. We call this the mole ratio step. Okay? In the mole ratio step, you look at your moles and you always take the smaller one. In this case, this is the smaller one. Sometimes they'll be equal, most of the time they will not be, so you always take the smaller one. If they were equal, it would be a 1-to-1 ratio. In this case, it's not. So it always makes the smaller one equal to 1. And when you do this one, this is that case, that's the exception I told you about. You're going to get 1.499 something, which is the 1.5 ratio. So in a case like this, you actually have to do one more step because you can't have a 0.5 either. You're going to multiply these both by 2. And so the formula becomes Mg3 P2. I'm going to put the name, I'll just put the name down here. It'll be magnesium phosphate. And by the way, this problem will stay up here on this board so you can look at it. So that's the, again, the 4 steps. The last step I didn't really change color or anything. The last step we just plugged in. So I'll just kind of redo that in black here. We plugged in the numbers we got here to the formula and wrote the name like we learned at the beginning of the year. All right, so that's the first question. We just answered the first question. It took 4 steps to get there. So it's not the easiest thing you ever did. Next one is a lot easier. This is percentage composition. Percentage composition is always just by mass, which is very easy for us because we already have our masses. So we're going to take the 31.9 grams of magnesium over the total mass, which is that compound mass. And we'll get a number here in a second.
54%.
54 what?
54.06.
54.1% magnesium, so there's a little more magnesium by weight. And then we're going to take the mass of phosphorus, the 27.1 grams of phosphorus, over that same total, 59. Oh, one thing I kind of left off here. You multiply by 100 to get a percentage. Sorry about that. And this one you get
45.9.
and that's the percentage of phosphorus in this compound. Okay? This is another sample of the thing we start on Friday. So you can look at this and also have this one exception where sometimes you have to multiply, so hopefully those of you who are struggling, this will help you at that time.